Welcome to How to Draw a Graph. Okay, there are three types of graphs we're going to be looking at in this course. There's going to be the linear graph, where you basically got a linear scale, 0, 1, 2, 3, and then you've got 1, 2, 3 going up. And that's just a straight, ordinary linear graph. We're also going to do a semi-log graph. Semi-log. And what that has is it has an ordinary scale down here, 1, 2, 3, and then it's going to have a log scale going up here. So this might be 1, 2, 3, 10, 20, 30, 100 and so on. And we're going to have also look at the log graph. So that's going to, not going to have a linear scale again, it's going to have a log scale, so that when you look at this log scale, they're not evenly separated. There's a big gap between 1 and 2, and then it gets smaller between 3, and then 4, 5, 6, 7, 8, 9, 10. And then once we get to here, 1, 2, 3, again, we have a big gap between 1 and 2 and 3. And we have the same thing going up. And we'll look at these in more detail, but this is good for plotting straight line graphs, and we want straight line graphs because we can use very simple formulas and very simple equations. But if we have a line on a straight line graph, if I stick in a value of x, I get out a value of y. But if I stick in a value of y, I can find all cases of x where it's true. And this is very useful in engineering. Semi-log graph, the point of that is that this is good for doing parabolas and other non-linear, non-straight line graphs and turning them into a straight line. And the third type of graph, the log-log graph, will turn just about anything into a straight line. And in fact, in astrophysics there is a saying that you can turn anything into a straight line graph if you use a log-log graph and a thick enough felt pen. And the whole point behind these is that you end up with a straight line which allows you to make easy predictions. So what do we need in a graph? If in a graph we have to have a set of axes, and the axes must be labelled. So this might be time, and it must have a unit, seconds. And this might be velocity, and that's going to be in meters per second. And the graph must have a title. So this might be distant time. We always put the y-axis first, velocity versus time, but it must be for something, for a car. I mean, if you ever look at the contents of a thesis or something, it'll have a list, or in a book it'll have a list of figures. You don't want to look down there and just see D versus T, D versus T, D versus T, D versus T. You want to see what the graphs actually mean just by looking at the labels. Then what you do is you'll plot your data points on your graph. And if they're pretty much a straight line, once you've plotted your data points, you're going to put a line on there. If it's a straight line graph, you take a ruler, choose two data points. I'm going to choose this one and this one. This is going to be my point 1, this is going to be my point 2. You then grab a ruler, be brave, and put a straight line through there. Please note, it does not have to go through 0, 0. In fact, often the whole point of drawing a graph is to find how much it misses thereby. Because this could be some constant, like how much energy is required to get something moving, or in this case it shows at time 0 this car was not at a standing start, it already had a little bit of velocity. So it's important that you draw that. If you have a data set, say you have a graph like this, and the data is obviously not linear, in that case what you do is you grab a pen or pencil and you freehand a curve on there. One single smooth continuous line. Do not try and connect the dots, but smooth continuous line, and that's your basic graph. So we'll be looking at each of these types in detail in a second. We'll also be looking at how to find the uncertainties on the graph, how to find the gradients on all three graphs.